Hi, next we're going to look at the second special case, which is this right picture where we think we have two distinct equations, but it turns out we won't. But let's take a look and see what happens. So this is the infinitely many solutions case. So I'm looking at these two equations, 2x plus y equals 5, 4x plus 2y equals 10, and I'm told to solve it. So I look at them and they're both in standard form and the x's and y's are lined up. So I think I'll use elimination. And i's are drawn to the x's. I'll try to make the x's the same. So I'm going to look at equation 1 and try to rewrite it so that it has the same coefficients as equation 2. So I'm going to multiply this whole equation times 2. So I call it 1 prime, my 1 prime equation. Actually, you know what? I'm going to switch to letters, A, and B. All right, so A prime is going to be 4x plus 2y equals 10. And B stays the same, is 4x plus 2y equals 10. And right then I'm like, uh-oh. When I go to eliminate, I'm going to use subtraction. X's cancel, y's cancel, 10's cancel. I get 0 equals 0, which is true. Okay, so remember what that means. It means that what we started with was true, which means that in this particular case, all the numbers work. Well, not all numbers, but all x and y's that are on one equation work in the other equation. And we can see that these two equations are equivalent because when we multiplied by 2, we got equivalent equations. So if the equations are equivalent, we have, what do we call it? We call it infinite solutions. Okay. So, and looking at our graph, if they both come out the same, that means their slope is the same, and their y-intercept is the same. Okay. So if we put them in slope-intercept form, it means if they're the same line, they have the same slope and the same y-intercept. And I'll leave that as an activity for you to rewrite each of those in slope-intercept form. All right, so let's take a look at a word problem. Okay, so you're given this problem. The perimeter of rectangle A, and here's a picture of it, is 36 units. And remember, perimeter is the distance around. So you're going to go around and you're going to go 4y twice and 2x twice. So we get 4x plus 8y equals 36. And rectangle B is 12y and 6x. And they did the calculation here. Double the length, double the width. Right? So it looks completely different equations, right? Nothing jumps out at you. 4x plus 8y equals 36, 12x plus 24y equals 108. And so I want to use elimination. Right, I'm not sure if we've shown you this before, but usually we multiply up to make the coefficients the same. But these numbers are getting kind of big. So I notice that the second equation, 12x plus 24y equal to 108, I can divide it by 3, and then I'd have the same coefficients on the x. So we don't always have to multiply, we can divide. So I'm going to keep equation A the same, and I'm going to change B. So I'm going to divide everything by 3. 4x plus 8y. Program my calculator, 36. And that's when I realized, wait a minute, I don't really have two distinct equations. It's really the same equation in disguise. I do my subtraction, 0 equals 0, true, infinite solutions. Okay. So you can see how you could start off thinking you had different equations, but when you did a little algebra, realize, oh, they're really not different. So in summary, I just want to kind of recap the three pictures that you saw. So I would definitely be studying that key idea and maybe even drawing here. One solution, oops, I don't want it there. Maybe off here, in here. One solution means our two lines cross at a point. And that will happen if the slopes are different. Okay, and the y-intercepts actually could be the same, or they could be different. No solution, same slope. Let me change the color. It stands out a little bit. Same, but the y-intercepts have to be different, because to get parallel lines, I need the same slant, but them to start at different spots. And infinitely many, that's really the same line. So the slopes are the same, and the y-intercepts are the same. All right, and again, I'm going to leave that for you to fill in some examples.